Well, hey guys, in the previous video, we introduced this idea of depreciation, where something that you have goes down in value over time. And we looked at the first of two types. The first one was called straight line depreciation, where we just take the same amount of money off every year or every time period. But in this second one, we called declining balance depreciation. We're going to take a constant percentage off. So let's go through and actually break down an example, and you'll get an idea of what I mean by this. Okay, this occurs when an asset depreciates by a constant percentage rather than a constant amount. So, example, let's say we buy this car for $40,000, okay, and it depreciates at a rate of 10% per year. What's it worth after 5 years? Well, I'm going to do this step by step. So let's have a look. Let's do a little table and we'll do some of the calculations and see what's happening. Okay, in the first year, the original value was $40,000. So how much does it depreciate in the first, or over the first year? Well, let's have a look. It depreciates by an amount of 10%. Okay, now remember, whenever we're doing the sort of percentage calculations, we don't use the percentage, we use the decimal equivalent. So we divide it by 100, we turn it into a decimal of 0.1. So taking 10% off something is the same thing as keeping 90%, right? If I chop off 10%, I'm keeping 90%. So the value of the car that we're keeping is actually 90% of the original, because 10% is being taken off as depreciation. So 40,000 times 0.9, which is 90%, written as a decimal, means that the current value at the end of the year, or the salvage value at the end of year one, is $36,000. It was 40,000. We've taken off 10%. In other words, we kept 90%, and we got 36. So at the start of year two, that is our original value. So let's take this number, shift it down here. So at the start of year two, it's worth 36,000, and I'm going to keep 90% of that. I'm just going to repeat what I did in the row above. 36,000, keeping 90%. So what's 90% of that? Multiply them together, and at the end of year two, it's worth 32,400. That's our new salvage value, our new original value, sorry, for the start of year three. So I'll drag that over here and repeat the process. Times it by 0.9. At the end of year three, it's worth that. Let's do the same. So that's the value at the start of year four. And hopefully you can just see the process has been repeated. Now, after doing this 5 times for 5 years, I've got down to a value of 23,620. Okay, every year just taking 10% off the previous year's value. Now, luckily, we don't have to do that for every type of these questions, because that's, you know, a bit of work drawing up a table. Now, you could if you wanted to, but there is a faster way. We can use this formula here. Let's go through what each of these mean. S, remember from our previous video, means the salvage value, like what is the value now after it's been depreciated. VO was the original value, what it was at the start of the depreciation period. 1 minus R. R here is the rate written as a decimal. Okay, so if it was 10%, we do that as a 0.1, and to the power of n, which is the number of time periods. Now, this may look familiar, this particular equation here. I'm going to come back at the end of the video and see if you could recognize it. But let's just apply it for the moment. We've got our original value, number of time periods, the interest rate as a decimal, and the salvage value. All right, so let's see if we can apply this formula now and see if we get the same result as we did when we got when we did the table. We've got our original value of 40,000. That's the VO. Our number of time periods was 5 years. The R, the rate of depreciation, is 0.1 because that's 10% written as a decimal. So let's go ahead now and just simply insert or substitute each of those values into our equation. So our equation becomes this now. The salvage value equals 40,000 times 1 minus the rate, which is 0.1, all to the power of 5. Punch that into your calculator and we get a value of 23,620. Lo and behold, that's exactly the same as what we got when we did the table. Much quicker, obviously, much easier to use this equation right here. So just wrapping it up, If the asset depreciates by a constant percentage, we call that declining balance method, okay? If it depreciated by a constant dollar value, like the previous video, we'd call that straight line depreciation. They're the two that we're going to learn about in this course. Now, I mentioned earlier that this little formula looked familiar. In fact, if you have a look at it, it's very, very similar in structure to our compound interest formula for future value, where the present value outside of 1 plus r to the n. It's identical except for the fact that instead of adding a rate, we're subtracting, which makes sense when you think about it because our values are coming down. So it's almost identical. It's effectively compound interest, but in reverse. It's kind of like compounding depreciation. So if for some reason you forget the formula, but you can still work off the compound interest one, just remember we're taking off a value. So we're going to subtract instead of add. All right, guys, good job. Well done.